Hey everyone. So in this video we are going to see how the spanning tree protocol converges, basically how the root bridge selection happens, how the root ports they get elected, the designated ports and the alternate ports. To understand this, I have created a simple topology. Here you can see we have four switches. I have named the first two switches here as egg R1 and egg R2. Don't get confused by the name R1 and R2. These are basically L3 switches. Okay, consider them as switch only for time being. And I have two more switches at the bottom. So total four switches. All these four switches are connected by the trunk links. Uh, Here I have created a port channel between these two switches, and we are going to see how the spanning tree converges in this kind of topology. Okay. So before I go there, let me first give the talk about the path cost. Okay. So here all the links are fast Ethernet links, and the cost is 19 for all those. As you can see here on all the links 1 2 3 and 4, and but in this link the cost is 12 because I have done the port channeling, and the cost has the default cost what I have got is 12. I'm going to see all these things in my configuration as well, but let us first see theoretically which switch is going to be elected as the root bridge, and how the root ports and other designated ports, alternate ports, will be selected. So whenever a spanning tree protocol converges, the first step of the protocol is to select the root bridge. So to select the root bridge, it looks at the uh, priority. Here you can see the priority is same everywhere, 32768 on all the switches. And next it will look at the MAC address. The MAC address of this switch here is 201, starting with C201, this C202, C203, C204. So the lowest bridge ID, which basically consists of the priority and the MAC address, okay, wins. So because we have priority same everywhere and the MAC address is lowest for switch 102, this switch gets selected as the root bridge. So this is the first step of spanning tree protocol convergence. So let me write here. So this is going to be my root bridge. Okay. Now, once I have selected the root bridge, the next step of spanning tree protocol is to select the root ports on all the individual switches. So let's first come to the R2 switch here. So it has the three links, 1 2, and the third one is the port channel. Here if you see the cost to reach to the root bridge, okay, from this link it is 19. Okay, on this link it will be more than 19. Okay, the BPDO will first go from here to ag R1, then switch 101, and then finally it will come here. So of course it is going to be more than 19. And similarly for the BPDOs which are entering from this port channel, the cost will again here be more than 19. So among these three links, this port of fast Ethernet 0/2 is going to be the root port. Okay, so let me write here, this is going to be my root port. Okay, all right. Let's do the same thing on the other switches. This is the next switch. Here I have again the three ports. Out of three ports, the cost to reach the root bridge will be minimum for this interface fast ether 0/2. You can see here it is 19. if I see here, it will be 12 plus 19, which is going to be more than 19, of course. And similarly from here also, the cost to reach the root bridge will be higher than more than 19. It will be 19 plus 19 and then plus 19. Okay, and hence in this switch, the root port will be fast ether 0/2. Let me write it here. All right, and then coming to the last switch here. Now I have two ports here. Forget about this port because this is the access. This is the access port which is going to my end host. Okay. So between these two interfaces, uh, let me first calculate the cost to reach to the root bridge. So if you see from here, the cost will be 19 plus 19, which is 38. Similarly from this, again it will be 19 plus 19, which is 38. Hence the path the path cost to the root bridge is 38 for both the interfaces, and hence I have to go to the next tiebreaker, which is the bridge ID of the upstream switch. Okay, so if you see for this link, my upstream switch is here, AG-R1, and for this link my upstream switch is AG-R2. Okay, and the bridge ID of AG-R1 is lower than AG-R2. You can see here it is priority is same, and the MAC address here is C203, here it is C204, and hence this port wins the race. Okay, because the upstream bridge ID is lower, and hence between these two ports, this is going to be my root port, fast ether 1/0. Let me write it here. Okay, yeah, so this is root port, and also all the ports on the root bridge, they are going to be designated ports. Okay, I'll come to this now. So once we have the root port selected on all the switches, next is the selection of designated port and the alternate port, which will be in block state. So all the ports on on root bridge will be designated port. So let me write here. This is going to be designated port, and this is also going to be designated port. Okay. Now let's talk about this particular this link. Okay, the link which is connecting AG-R1 and AG-R2. So here if you see the way the designated port election happens is, we have to calculate the root port cost to reach to the root bridge. Now what is root port cost? So here if you see, when I'm talking about this particular switch AG-R2, cost to reach to my bridge ID root bridge via the root port is 19, and similarly for this switch, the root port cost, which is basically the cost to reach the root bridge via root port, it is 19 again. So from here also 19, from here also the root path cost is 19, and hence I will go to the next tiebreaker, which is basically the local bridge ID. So for this particular switch, bridge ID is higher. I can see here it is C204, and for this it is lower, C203, and hence this, when I'm talking about this link which is connecting these two switches, this port wins the election, and hence this is going to be selected as my designated port, and as a result this will be my alternate port, which will be in block state. Let me write here designated port, and this will be my BP block port. Okay, Yeah, so I have this link has been taken care. Now let's come to the next link, which is uh, this link, the link between switch 101 and the AGR2. Now on this link, if I see the for this particular port, basically the cost to reach the root bridge via root port is 19. Okay, and when I'm talking about this here switch 101, the root path cost to my root bridge is going to be 19 plus 19, which is 38, and hence which is higher, and hence this particular port wins the election in this link because the root path cost is lower, and hence this is going to be my designated port. Designated port, and this port will be my, sorry, this will be block port. Okay, so I guess all the uh, links have, all the ports have been taken care. Yeah, so the port in this link, okay, this is the root port, and the, of course if it is one on one link, if one of the port is root port, other port is going to be my designated port always. So this is my designated port. Okay, yeah, so everything is now taken care. So my root port and designated port, they will be in forwarding state, and my block alternate port, which will be that will be in block state. Okay, so let us verify by logging to the devices. So let us first log into switch 102. So ideally should be my root bridge as per my theoretical calculation. Let us go ahead and verify it. Let me log in here. Okay, I have already created 3 VLANs. So let me quickly verify for VLAN 702. So spanning tree VLAN 702 brief. Okay, so here you can see uh, root port address is this, which is same as my bridge ID, and hence this particular switch is acting as root bridge. Okay, which is what we had seen as per our theoretical uh, calculation, and all the 3 interfaces, okay, they are in forwarding state. So I am seeing 3 interface because it has taken this interface as well. I am yet to configure so this interface is access port, which will be in forwarding state. Okay, so 101/0 1/1, then forwarding state. Let me check. So spanning tree VLAN 702, what is the root port? So I won't have any root port here because this is my root bridge. Yeah, cool. Let me log into the next router, next switch here. So here I can see one of the port will be in block state, which is basically the port channel. Rest 2 will be in forwarding state, and FA0/2 will be my root port. Let me log in and verify. So VLAN 702 brief. Okay, so here you can see my root ID is 201 C201, which is basically the MAC address of the previous switch which I had logged into. Now here you can see the port channel 1. Okay, it is in blocked state, which is true as per our theoretical calculation as well. and the other two ports, these are in forwarding state. Now let us quickly verify which should be the root port. So if let me go to the topology, as per theoretical calculation, F fast Ethernet 0/2 should be root port. Okay, let's see that. So spanning tree VLAN 702 root port. Okay, sorry guys. So you can see, you can replace, it's not 0/1, it is basically line card 1 which is being used. So all these interfaces are 1/2, 1/1, and here also it is 1/2, 1/1, and so on. Okay, so this is 1/1, which is my root port, which is correct. Okay, let me correct here. 1/1, here it is, sorry, it is 1/1, that was 1/2, here also it is 1/2, here it is 1/1. Okay, yeah, so that is correct. Let me log into the egg R1. So here you can see all the ports, none of the ports are in blocked state here, and the root port is going to be fast ether 1/2. Let us verify that. So span entry VLAN 702. Okay, so none of the ports are in block state, all are in forwarding state, and my root port should be 1/2. Let's verify that. Show spanning tree VLAN 702 root port, which is 1/2. This is correct. Okay, let me go to the last switch, this one. So here, out of the two interfaces, I'm not worried about this interface because this is the access port, which will be in forwarding state. Okay, between these two interfaces, one will be in block state. Okay, the other one, fast ether 1/0, it will be in forwarding state, and that will be my root port. So let us verify that. So let me go once again. So 1/0 should be my root port. Okay, so spanning tree VLAN. So you can ignore 1/2 for now. This is access port. I'm worried about these two interfaces. So you can see 1/0 is in forwarding state, and 1/1 it is in blocked state. Okay, 1/1 should be in blocked state, 1/0 is in forwarding state, and 1/0 will be my root port. So span tree VLAN 702 1/0 is my root port. Okay, so yeah, so that's it about the spanning tree protocol conversions. uh, Many engineers, they have confusion mostly about it's pretty straightforward to do the calculation. However, there is, I have seen many people getting confused when it comes to the election of the designated port. So hope this video would have been helpful to understand how the election of all the ports and the road bridge takes place. Thank you.